In this problem, we have a baseball that hits a fixed rigid wall at a speed of 50 feet per second, which is at an angle with the horizon. And we know the coefficient of restitution between the ball and the wall is 0.75. We need to determine the speed of the ball after it rebounds from the wall. So in this problem, we cannot treat the ball and the wall as one system and apply the conservation of linear momentum. The reason is because, as you can see, this wall is fixed to the ground. Therefore, during this collision, when the ball hits the wall, there is actually external force here that could affect the total momentum of the system. Therefore, for that reason, we cannot apply conservation of momentum equation to this problem. However, we still have this relation that we can use because the wall is fixed, which means that before and after the collision, the velocity of the wall is always 0. So that's very important. Okay, so because collision only occurs along this line, so we need to resolve the velocity of the baseball into x and y components. So we will have v1x and v1y. So v1x equals to v1, which is 50 times cosine 30 degree, and that equals to 43.3 in the unit of foot per second. v1y equals to 50 times sine 30 degree, and if we follow convention, it's actually negative because it's pointing down. So because the collision only occurs along the x direction, therefore when we apply the equation, it is only applied to the x direction. So E equals to, again, the departing relative velocity, the velocity of the wall, which is 0, minus v2x divided by the initial approaching relative velocity. So that will be v1x minus the velocity of the wall. Again, that's 0. And that equals to negative v2x divided by 33.3, which is v1x, and that equals to 0.75. So from there, we can solve for v2x to be negative 32.5 and the foot per second, and the negative sign indicates that the velocity is to the left. Now, because there's no collision along the y direction, therefore along the y direction, the velocity after collision is the same as the velocity before collision, and that still equals to negative 25 foot per second, which means that it's vertical down again. Therefore, if we use green color to represent the velocity of the baseball after collision, it will have the same velocity, 25 foot per second down, but at the same time, along the x direction, it will be a velocity of 32.5 feet per second to the left. As a result, the magnitude of the velocity of the baseball after collision, which is the speed of the ball after it rebounds from the wall, equals to square root of v2x squared plus v2y squared, and that equals to 41.0 in the unit of foot per second.